given to you is R is set of all these matrices where the entries A, B, C, D here belong to this set. There are total 8 numbers you can count, including 0. Then the number of invertible matrices in R is. So how many invertible matrix we can have? So basically it's a counting problem. How many invertible matrices we can have? So when do you think a matrix is invertible? When the determinant is not 0. What's the determinant of this? Calculate quickly. Maybe you can open using the last row. Okay, 5. So minus 5, and what's the minor of that? AD minus BC. Okay, what do you want? You don't want this to be 0. You have to calculate, you have to count actually how many ABCDs are there such that this is not 0. How many total possibilities are there? How many ABCDs you can have? A can have all of the 8 values, B also can have all the 8 values, right? So 8 to the power 4, so C and D, anyone can take all the 8 values. Okay, 8 to the power 4 is total number of such matrices. Okay, such matrices as in total matrices. Okay, and you want the ones in which determinant is not 0. So if you subtract number of ways in which determinant is 0, okay, then you are done with. That's easy to count when the determinant is 0 rather than computing determinant is not 0. Okay, so let's go ahead and figure out how many ways I can have determinant to be 0. So I want this to be 0. What does that mean? That means you want AD to be equal to BC. Yeah. Okay, now look at the possible options. Whenever you have a 0, you have to be careful. Okay, so let's take cases. Let's say case 1 in which none of them are 0. So that means you have only 7 options. Okay, now again here also you have case 1. Okay, let me write case 1. What is that? Suppose A and D are same. Okay, so if A and D, for example, let's take A you have taken to be 3 and D is also 3. Okay, so A times 3 times 3. What do you think B and C is? You don't have an option, right? They're prime numbers. Okay, B and C also have to be 3, right? Similarly you can do with any, because you see, closely look, all of them are prime. Okay, so if you fix that A and D are same, then B and C also have to be the same. So if all are same, okay, that is how many ways it is possible. There are total 7, right? So this is possible in 7 ways that all are same. Now let's say case 2, I mean here in under case 1 there is a case 2 in which maybe A and D are different. So A you can choose in how many ways? There are 7 total ways, 7 total possibilities. So 7 ways. Okay, if you have chosen A, then how many ways you can choose a D? 6 ways, right? Because you don't want the same, right? Okay. Now if you have chosen A and D, don't you think B and C is fixed? Yeah, because take an example. Suppose A is 3 and you have chosen D to be 5. Now what can be B and C? There are two possibilities, right? Either 3 or 5 or 5 or 3. So with every such possibility, you have two more possibilities, right? For choosing B and C. So total ways how much? 7 times 6 times 2. Okay, how much is that? 84. Okay, so you got total 84 ways in which they are different. Okay, so 7 ways you had here and then you got 84 ways. So non-zero are okay. Okay, now let's go to case 2. Okay, so case 2 is that you are allowing 0. Again you have to take cases how many are 0. Okay, so case 1, let's say you allow 2 are 0, two of them are 0. Can you allow one or one is 0? No, right? Because you want AD is equal to BC, isn't it? If you suppose allow A to be 0, okay, that means your right hand side is 0. B, either B or C have to be 0, right? So 1 0 is not possible. So you start with 2 are zeros. Okay, now how many ways you can choose 2 are 0? Just check. Either you can have AC is 0, or you can have AB is 0, or you can have DB is 0, or DC is 0. 4 ways. Okay, there are 4 ways in which you can have two zeros. Okay, now 2 you have said is 0. Okay, now the remaining 2 can take any of the 7 values which are non-zero, right? There are 7 left. Okay, there are 7 non-zeros. So 7 times 7, that's 49. Okay, how many is this? 196. Okay, so 196 ways you can have two zeros. Okay, now go to 3. Okay, can you have 3 zeros? Of course you can, right? 3 zeros. Okay, how many ways? Tell me. Okay, so either of the 3 you can take to be a 0, right? So there are 4 possibilities. Okay, 4C3. Okay, there are 4 ways you can have any of the 3 to be 0. The remaining one can take any of the 7 values. Yeah, so 28 ways. Okay, now all the 4 are zeros. What? Yes, everyone is a 0, right? Only one way, everyone is 0. There is only one way. So now let's add all of them. How many total ways did we get? Okay, that the determinant is 0. Okay, what do you get? 7 plus 84 plus 196 plus 28 plus 1. Okay, how much is this? Just add them up. This happens to be 316. Okay, what you have to do? 8 to the power 4. How much is that? 64 square. That is 4096. And then you subtract 316 from there. How much do you end up in getting? 3780. Okay, this is the total number of ways you can have invertible matrix. So determinant, so number of invertible matrix is in R 3780. Very nice question. It's kind of counting problem, okay, not a determinant problem. See you with another one.